So this is pretty much same layout as Java 1. We're going to cover chapters 8 through 13 over 6 weeks. You already have Eclipse installed, so we should be ready to go right out of the box. So do you have Eclipse up? Okay. So let's come over here and let's go to classwork and source files. I'm going to click this link right here. I'm not going to do anything down here. I'm going to click right here, and I'm going to download chapter 8.zip. And then back over here in Eclipse, I'm going to do File, Import, and under General, I'm going to click Existing Projects into Workspace, and Next. There I'm going to click on the drop down. I'm going to go to wherever I downloaded chapter 8. I happen to be in Downloads. Chapter 8, I'm going to click Finish, and I should see Chapter 8 over here in Project Explorer. Did you get it? Okay. So the first thing that Chapter 8 talks about is what are called static class members. And a static class, so when we see the word static, we've seen it so far, we've seen it with public static void main. And what that means is that particular item belongs to the class. It doesn't belong to the object. So when we create an object and there's a static in there, that static doesn't go with the object that we're creating. It actually goes with the class itself. And it'll make a little more sense once we kind of get in here and take a look at this. So, hold on a sec. So, let's take a look at, let's open up, so I'm going to expand Chap 8. I'm going to click on Countable. And what we see is we see public class countable, and then we see private static int instance count equals 0. So this is our class, and this is basically an instance variable, but it's kind of a weird instance variable because we have this word static right here. So what I said is it belongs to the class and not the object. So I'm going to open up the static. Well, let's see what it does first. Okay, let's see what this class does. So I got private static int instance count equals 0. So I got this instance variable called instance count. It's initialized to 0. Here I have a constructor called countable, and all it does is it says instance count plus plus. I come down here and I got get instance count, and it returns the instance count. Okay. Let's open up static demo, and let's take a look at this guy. And here it's got int object count. And then down here I've got countable object 1 is equal to new countable. Countable object 2 is instantiated as new countable. And countable object 3 is instantiated as a new countable. So what's going to happen is each time that object is created, this constructor is going to get called. But again, we got this word static in there, so we don't know what's going to happen there quite yet. So down here I'm going to say object count equals object1 dot get instance count. Okay? That's going to say object count. So this object count up here gets set right there. Instances of the class were created. Now, in a normal world without static, that should only have 1 in there because we're only going to count at 1 for each object. But watch what happens. When we run this, it says 3 instances of the class were created. Because here's what happened. This static int instance count belongs to this class. So every time I instantiate an object from that class, and that constructor gets called, it adds 1 to instance count. When I created object 2, that same instance count is going to get added to. So it did not create an individual instance count by object. It just got created by the class itself. Does that make sense? So the main thing we want to push here is, since it's static, it belongs to this class, and so each object is basically sharing this instance count. So when object 1 got instantiated and that constructor got called, it added 1 to the instance count. When object 2 got created, it did the same thing. It added 1 to that instance count. And then object 3, so when it came down to here, now if I were to print instance count for object 2, I would get a 3. If I say print instance count for 3, I would get a 3 as well. So now that's a static instance variable. What happens when we add static to a method? Now we've seen the public static void main. So let's open up metric. And here I see public class metric, and I see public static double miles to kilometers, and it's expecting to receive a double, and it's going to pass back a double. And it just says return whatever this m is multiplied times 1.609. Down here I've got public static double kilometers to miles, and it's expecting a double being passed in k, and it's going to just take k and divide by 1.609, and it's going to return a double. If we take a look at metric demo, we'll see that I've got public class metric demo. Here's my public static void main. I create 3 variables: string input, double miles, double kilometer, or double kilos. And I create a new decimal format called FMT, and it's going to have 0.00. And then I'm going to use a J-option pane to say enter the distance in miles. And I'm going to say miles equals double dot parse double input. So it's going to take that string, convert it to a double, put it into miles. And then I'm going to say kilos equals metric dot 2 miles 2 kilometers. Whoa. How can I just call miles to kilometers without instantiating an object? Well, the reason being is, since this word static is right here, that says this guy can be used right out of the box. So this is kind of like opening up a new tool and batteries are included. It's already ready to go right out of the box because static says this belongs to the class and it can be used right now. You don't have to instantiate an object or anything like that. You can just use this method right out of the box without anything being instantiated. So when it just says metric, here's the class, and since miles to kilometers is already created in static memory, it basically miles to kilometers we can use it right out of the box. Now, if I were to take out the word static and save it, when I come over here, notice that miles to kilometers is red. And the thing it says is, hey, you need to change miles to static, or you're going to need to do something like this. You're going to need to say metric is equal to new metric. And then down here, this is now an object, and now I can call this. So once I instantiate this, now I can call miles to kilometers. But I don't have to do any of that when I make this static. Now that it's static, I can use it right out of the box. I don't have to instantiate an object before I actually use it. So metric.miles to kilometers. Now we've seen some of this in the past. We've seen this where we've had other, I can't remember right off the top of our head, where we actually just used, well, math is one of those. Math.pi and math.pow and those such things. Those are basically static methods within the math class so that we can use those methods right out of the box. We don't have to instantiate a math object in order to use them. So I just say kilos equals metric.miles to kilometers. I pass on miles, and it converts it to kilos. And then we're going to show a JOption show message dialog and say FMT format miles to kilometers. It's going to basically show the conversion. And then I can ask a JOption pane show input dialog, enter a distance in kilometers. I convert that to a double, and then I call metric.kilometers to miles, and basically do the same thing. So it's kind of nice is if you just need a method that can be used for like calculations, that type of thing, you can actually put it in a class and then make that method static. That way there you don't have to go through the whole instantiating an object or that type of thing in order to use that method. You can just use that method because it's a static method. So let's run this. And distance in miles, we'll say 100. And converted to kilometers is 160.90 kilometers. And then we basically inner distance in kilometers, I'm going to go ahead and say 100. And we convert that to miles. It says 100.00 kilometers equals 62.15 miles. So any questions on static methods? Okay. On page 500, we talk about passing objects as arguments to methods. So let's open up passObject.java. And this is going to use a rectangle class. We've already seen the rectangle class. I don't think there's much difference. We got our two instance variables, length and width, are both doubles. Here's our constructor where we pass in a length and a width, and it sets those two instance variables. I've got a set length, set width, get length, get width, and I've also got get area. Okay, so we've seen that before. So I got I'm creating a box object from the rectangle class, and I'm passing in 12.0 and 5.0 as in the constructor. And then I've called display rectangle box. So I come down, so I'm passing the object box to the method. So down here I'm passing box as a rectangle object called R, and it says system.out length r.getLength width r.getWidth. So I can pass an object to a method and then utilize that object within that method. So simple enough, it's going to get the length, get the width, which happens to be 12.0, 5.0. And when run it, there it is. Length, 12.0, width, 5.0. So nothing really too new there, just being able to pass an actual object to a method. On page 501, again, when we pass box right here down to display rectangle, we're actually passing the address of the object. So when we if we were to modify this object down here, R, it's the same thing as box. So box and R are the same thing. They just have two different name tags. And this method up here, it's got a name tag called box. Down here in this method, it has a name tag of R, but they're the same exact object. We're just passing the address. Let's take a look at pass object 2. And there I've got rectangle box equals new rectangle 12.0, 5.0. So we're creating a new object called box. It's a rectangle object. We print the contents of the box object. There's length, box.getLength, width.getWidth. So nothing new there. Then I got change rectangle box. So I pass the rectangle box down here, and this time I want to say r.setLength 0.0, r.setWidth 0.0. So when I come up here, and now the contents of the box object are length, box.getLength, width.getWidth. So if we were passing by reference, or by value, I should say, if we were passing by value, we would basically get two sets of numbers, or the same sets of numbers here in this method. Because when we pass by value, we are just passing the value of that. But we were passing reference, I mean we're passing the address of this object. So again, up here it's got a label of box. Down here it has a name label of R, but they're the same exact object. So when it's ran, so up here it had get length, which was 12.0, 5.0. That's what we see here. But down here we set the length and set the width to 0.0. And when we come back up here and display the length and the width, we get 0.0 and 0.0. So just be aware that when we pass an object, we're just passing the address of that object. Okay, so we can pass objects to a method. We can also get objects back from a method. So let's open up return object.java. And here now this is kind of wild. I just create bank account and account. Now remember, when we do that, so think of the left-hand side of the instantiation. We just created an empty shell of a bank account. It has no guts in it right now. It's just an empty shell. Then I say account equals get account. So I come down here, and here it basically has a public static bank account. So it's going to return a bank account object. So I got a string input, double balance. I use a J option pane, enter the account balance. I put that into a string, and I use the double.parseDouble to convert input into a balance. And then I say return new bank account balance. Do you see what we're doing there? With this is instantiating a new object with the balance. So this guy is going to call the constructor of that new object. So up here, account is sitting with that, because up here it was created as an empty shell of a bank account. This guy says account equals get account. This then creates, instantiates that object, calls that constructor, loads up the bank account starting balance, and then basically sets the account with that information. So the empty shell is created here. The guts are added here. And then we can say the account has a balance of $, account.getBalance, which should be what? Oh, we're going to ask the user for the amount. So we run it, and it says enter the account balance. We'll say 500. We run it, and it says the account has a balance of $500.0. So any questions on instantiating an object via a method? That's basically what we're doing here. Okay. Now what happens if I take the word static out of here? Does that cause any issues? It sure does. because this guy goes, I, I can't instantiate from a method because I'm expecting an object to be there. But since it's static, since it's a static down here, it basically makes it so that it is, it lives in the class itself and basically makes it so that everything is good to go right out of the box. We don't have to instantiate anything. We can actually just do the instantiation as a return and place the guts into that empty shell of a object. Okay, on page 505, we have the toString method. And the toString method is actually, it's built into most every object. It's already there. But what it's going to do is it's just going to return the hex code for that, which is the hex code. Think of every object has its own social security number. So it has its own identifying, I won't call it a number, but it's IDs, has its own identifying ID. So let's just take a look at stock. So down here I got stock class 1. Let's expand that package and let's open up stock. So we come down here and public class stock. I have two instance variables, string symbol and double share price. Here's my constructor. It's expecting a string and a double, and it's going to set the symbol from whatever the strings brought in and share price from whatever the double is brought in. Down here I got get symbol. That's going to return the symbol, which is going to return a string. Here's double get share price. Again, it's going to return the share price, which is a double. Down here I have a toString method. Now, we're going to see that we don't have to call the toString method because we can actually use the automated process. We'll see what that does in a sec. But when this is called, it's going to return a string. So we create a string called str, and it's going to have trading symbol, colon, symbol, excuse me, new line, share price, colon, and then the share price. And then we're going to return that str. Let's take a look at stock demo 1. And we see that within our public static void main, I say stock XYZ company is instantiated as new stock XYZ and 9.62. But look at this. If I just say system.out print, just print the object. Well, whenever we try to print an object, what that tells the compiler is print the toString method. That's what that says. So if I say print the object, it's going to print the toString. Now, let me show you this. I'm going to comment this out. Just watch me. You don't have to do this. So I just commented out the toString. So now, when I say print this, it's going to print the default toString method, and you'll see what that looks like. So when I run it, there it is. Talked about its unique identifier, its own social security number. Well, this is it. It says the stock class 1, which is the name of our class up here. So stock class 1. Is that no? Wait, that over here. Yeah. So here's our it's using the it's using the package. So it's using a package. It says within the package stock class 1, we have an object with the number stock at E580929. So that's the identifying number from that. So that's the default toString. Well, we normally don't ever want to print that. What we want to print is what we have down here in our toString. So now when I save this And now when I run stock demo 1, look what prints. The trading symbol XYZ, share price 9.62. So that's basically what was printed right here in this toString. So again, what a toString does is it creates a string and it returns a string. Right here it says that I'm expecting a string to be returned. So this guy, when it comes back, it's in a print ln. It basically prints that string that is returned. Any questions on a toString? Okay. Okay, let's so let's go over to page 551, and we're going to do the area class. And let me do this. So let's open up this stock class 2 package, and there I've got stock compare. Okay. So first of all, if we open up stock, I believe it's the same exact stock. We've got string symbol, double share price. Here's our constructor, which we're expecting a string to be brought in and a double, and it sets the symbol and it sets the share price. Then I've got my get, I got my 2 gets, I've got my toString. The last thing I have is this thing called equals. So it's expecting a stock object to be passed in to this method. We create a Boolean status, and we say if symbol dot equals object2 dot symbol, and remember the double ampersand, share price is equal to object2 dot share price. Now notice what we did here. I used a double equal sign for primitives, but I used a dot equals method, which is built into the string class, for these two. If those things are true, it's going to set status to true. If either one of those or both of those are false, it's going to change status to false, and then it returns status. So notice up here it returns a Boolean, so it's going to return a true or a false. So whoever calls this equals is going to get true or false. So let's take a look at stock compare. So here I've got my public static void main. I create 2 stock objects. I got company 1 and company 2. It's instantiated as a stock XYZ 9.62. Company 2 is instantiated as new stock XYZ 9.62. I say if company 1 dot equals I. So here's that method. Here's the method that's built into the stock class. If those two are equal, it's going to print both objects are the same, else the objects are different. So when we run it, we get both objects are the same because it's XYZ, it's comparing XYZ to XYZ and 9.62 to 9.62. So it's comparing this instance variable to this instance variable, and this instance variable to this object's instance variable. Now, let's take a look at bad stock compare. So here we create our 2 stock companies. They're both the same. So XYZ 9.62, XYZ 9.62. This time I'm going to say if company 1 is equal to company 2. So if this object is equal to that object, it's going to say both objects are the same, else it's going to say both objects are different. So when I run it, it says the objects are different. Well, I'm going, they got the same name and they got the same number, but do you remember when I did that? I printed the object. When I said print the object, it printed that hex code with all of that information. Well, guess what? It's comparing these 2 objects, and the one thing that did not match are the 2 hex code. let me show you what I mean by that. I can print, so I can do an S, you don't have to do this. So SYSO, and I'm going to print company 1 and SYSO company 2. So it's looking for a 2-string. Does it have a 2-string? I want to make sure it doesn't have a 2-string before I do this. Oh, it does have a 2-string. Let me, I'll comment those out. So now when I run this, you can see why they're different. So there's, well, yeah. So there's company 1, there's this hex code, and there's company 2's hex code. They are different. That's why it says the objects are different, because I'm trying to compare 2 objects, and 2 objects are never going to be the same because of this code right here. So when you want to compare what's in an object, you have to compare instance variable to instance variable. You just can't compare the objects. Now on page 512, it talks about methods that copy objects. Now, as we saw in the past, if I say make this object equal to this object, what's going to happen, or I just say make this equal to this object, again, what it's going to do is it's going to use the same object, and it's just going to have 2 different name tags. So if I take this name tag and change something to the object, it's the same object, so it's not really doing anything different. So what we want to do is we want to do a copy. We want to create a method that copies one object to another object. So let's open up object copy. I believe that's in stock class 3. Yeah. Let's open up stock class 3. I think the stock is just the same. There's our 2 instance variables. There's our constructor. There's our get symbol, get share price. There's our 2-string, and there's our equals. And then we have one more method called copy. So here's what's going to happen. It's going to say, it's going to create a new stock object called copy object. And it's going to be instantiated as a new stock. And it's just going to use the existing symbols that's in this current object and the share price of this current object. And then it returns that object. So it's going to return a stock object. So if we look at object copy, so there I create stock company 1 equals new stock XYZ 9.62. Then I create a stock object called company 2, but remember the guts, there's no guts inside this. It's just an empty shell of an object. And then I say company 2 is equal to company 1.copy. Now the one thing we have to pay close attention to is, again, this is basically returning a stock object. So company 1.copy, this guy better be returning a stock object. That's exactly what it does, and it instantiates it as a new and places the guts in that side of that. So now I can say print company 1, it's going to print company 1. When I say print company 2, it's going to call company 2. So when it's expecting a 2-string. So when it says print the actual object, sure enough, there's the 2-string. So it's going to reprint trading symbol, symbol, share price, share price. So when we run it, there it is. Company 1, trading symbol XYZ, share price 9.62. Company 2, trading symbol XYZ, share price 9.62. Down here it says, if company 1 is equal to company 2, the company 1 and company 2 variables reference the same object, else it's going to print company 1 and company 2 reference different objects. And notice down here it says different objects. And the reason being is they have two different hex codes, basically the IDs. Okay. This next one is called aggregation. And aggregation is when we basically utilize another object as an instance variable. Okay? So if we look on the bottom of page 515, there I have an instructor class. The instructor class has three instance variables: last name, first name, and office number. We've got, looks like we have two constructors. One overloads the other one. One has a string, and the other one has an object to an instructor. Okay, so let's take a look at that particular guy. So let's take a look at instructor. So here's my three instance variables: string last name, string first name, string office number. Here is one constructor. Again, it's expecting string, which is last name, first name, office, and it sets those three instance variables. The other one is instructor object. Ooh, look at that. I can actually create an instructor object from another instructor object. So this guy is expecting instructor object to be brought in as object 2. And there I say object2.lastName, I put that into last name. And first name of that object 2, put that into first name. And object 2 office number, put in that office number. So what we just did right here is we just did a copy of one object to another. So we copied the three instance variables from object 2, which is an instructor, and put them in those three instance variables for this new instructor that's being created. I've got a set method, and it's expecting string, so it's going to set last name, first name, office number. I've got a toString, which basically creates a string variable that says last name, first name, office number, and then returns that back, again, as a string, and that's it. That's all instructor does. So it has two constructors. We either have to pass three strings, or we have to pass an instructor object to it to load those instance variables. The next thing we want to look at is textbook. So there I have public class textbook. Then I've got private string title, private string author, private string publisher. So title, author, and publisher. Here I've got my textbook constructor, expecting a string, or I can pass in another textbook object, where it's going to make a copy of that by taking each of the instance variables from the object passed in and place it in and copy them into those three instance variables. I've got the same set where I can pass in three strings to load those three instance variables, and there's my toString. It's going to print title, author, publisher. Put that into the string, and then that string gets returned. Now, here's where we get to aggregation. Let's take a look at course. So up here, I've got three instance variables. I've got string, course name, and here comes the aggregation. Private instructor, private textbook. So the instructor object and textbook object is an instance variable, otherwise known as aggregation. When we have an object used as an instance variable, that's called aggregation. Here I've got my constructor. I've got string, instructor, and textbook. So just a string, an instructor object, and a textbook object. Course name is going to be equal to name, what's passed in. Instructor is equal to a new instructor, INTSR. So this instructor object is going to basically be utilized to create instructor object. Now, this is the constructor of the instructor object. What's being passed in? Well, an instructor object is being passed in as the constructor, so it's actually going to call this constructor, because a signature is going to be an instructor object. Same way with the text. Textbook is doing the same thing. It's basically instantiating a new textbook object, and that's basically what is being passed in as the constructor. So when we get over here to textbook, this is the constructor that will be executed. Then I've got get name, return the course name. Get instructor, which returns a new instructor. So this is where it instantiates a new instructor object. Same way with the textbook. It returns a new instantiated textbook object. Here's my toString, where it prints the course, the instructor information, instructor, textbook information, textbook. So what is it doing right here? It's printing instructor. What's going to happen there? It's going to call the toString. When I try to print the textbook right here, it's going to come over here to the toString and print the toString of that object. So this is pretty kind of complex. We've got a toString that's calling other toStrings, and then it returns that string to whatever it's called, whichever calls it. So if we take a look at course demo, so here's where I create my instructor object. So instructor, my instructor, is instantiated as a new instructor with Kramer, Sean, and RH3010. Textbook, my textbook, is instantiated as a new textbook object, and we're going to pass in starting out with Java, and then Gaddis, Scott Jones. And then course, my course, is instantiated as a new course with the string intro to Java, and we're going to pass the my instructor object and my textbook object. And then I want to just print my course. So again, it's going to call this toString, which calls the instructor toString here and the textbook toString here. So when we run this, there it is. So it called that toString. It said course name intro to Java, the instructor information, and then it called the instructor toString, which last name Kramer, first name Sean, office number RH3010. Then it says print the textbook information. Then it calls the textbook toString, which has title starting out with Java, author Gaddis, and publisher Scott Jones. And what we could do, I could put a breakpoint right here, and I could run the debug mode. So go into the debug perspective, and we basically hit this instructor. And I can actually say, you know what, I want to go into that. So we're going to go into the, step into, okay, now we're there. So it's going to look at this constructor, and it's going to say, no, that's not the, oh, that's wild. Oh, I'm sorry. Yes, my bad. We just created that textbook object because I passed those three objects. So I created that. We come back. We come down here to new course. We're going to step into that. So we go into course. So I've got my constructor. So I've come over here. I got this. Here's course name is null, instructor, and textbook. So now when I step over this, course name is now Intro to Java. And we can instantiate this as the new instructor. So I'm going to step into this guy. We're going to instructor. So there's the object being passed in. If I expand the object, I can see first name, last name, and office number. So now when I step over this, it's going to grab the last name and put it into last name. So let me expand this. These are all null right now. Now last name is Kramer. First name is Sean. And now office, so it grabs the object to the office number, puts it in the office number, and now there's office number. Okay. We're back to here. Of course, textbook, and notice right now my instructor object has first name, last name, and office number. Textbook is null. So again, if I step into that, here we are. It basically automatically goes to the constructor with the textbook object signature. It basically grabs the object to title, which is starting out with Java, and it's going to put that into the title instance variable. There it is, starting out with Java. It's going to do the same thing with author. This author now has Gaddis, and it's going to do the same thing with publisher, and now publisher has that. You come back, and textbook now has all of that information in it. So we have, inside a course here, we now have a course name, we now have our instructor object, and our textbook object. We go back to demo, and we just did that, right? Yeah. So now we're going to call print my course. So I step into that. I don't want to do that. Well, I should have put a breakpoint side there. So